is a cartridge, the type of ammunition used in most small arms. It consists of a metal case, a bullet, a powder charge to drive the bullet, and a primer in the base to start the powder burning. A sharp tap with a pointed instrument will explode the primer, ignite the powder charge, and drive out the bullet. To control this powerful explosion and direct the bullet toward a target is the purpose of all small arms weapons. The term small arms includes shoulder weapons, hand weapons, machine guns mounted on ground tripods, on vehicles, and planes. Some are comparatively simple. Others are complex. But there is a basic similarity which runs through them all. Since they all fire the same type of ammunition, they all function in the same general way. In all of them, a cartridge is placed in the barrel and fired. The empty case is then removed to make room for the next cartridge. This process is called the cycle of operation, and every small arms weapon contains the mechanical means of performing it. To explain this cycle, let's construct a model weapon. It will not resemble any particular weapon, but it will include all of the basic features needed to perform the various individual steps in the cycle of operation. We'll start with a barrel. Removing the top half of the barrel, we can see inside. In the breech end is the chamber. This is where the cartridge fits and where the explosion occurs. Placing the cartridge in the chamber is known as chambering. A sharp tap on the primer would explode the powder charge and drive the bullet out. The same explosion would also drive the case backward out of the chamber. Therefore, the cartridge case must be held in the chamber, so most of the explosion will propel the bullet. The part which backs up the cartridge is usually known as the bolt. One end of this bolt fits against the rear of the cartridge and holds the case in place when it's fired. In order to hold the bolt in position, we need something to support it. The barrel, too, must be held in position. The piece supporting them is known as the receiver. There is a channel in which the bolt can slide. The barrel is attached to the front end. With this side section removed from the receiver and the bolt back, we can still chamber a cartridge by moving the bolt forward. This takes care of the first step of the cycle of operation, chambering. Instead of depending entirely on the weight of the bolt to hold in the case when the cartridge is fired, we'll use some way of locking the bolt in place. The simplest way of locking is to fasten a lug to the side of the bolt. A notch is cut in the side of the receiver. When we close the bolt, we can turn it so the lug fits into the notch and the bolt is securely locked. This is the second step of the cycle of operation, locking. It can be made easier by adding a handle to move the bolt. The handle can also be used to strike this stop. This prevents the bolt from sliding out of the receiver. With the bolt closed, how are we going to fire the cartridge? To fire the cartridge, we must strike the primer. However, the bolt is in the way. Apparently, we'll have to go through it. This bolt was prepared for that. The top half can be removed. It has a channel running through its entire length. All that is needed is a rod to reach from one end to the other. This rod is called the firing pin. You'll notice that it is slightly longer than the bolt, so its point will extend a little beyond the face of the bolt. We can now strike the primer by driving the firing pin forward. One way to drive the firing pin is by using a spring. We've put the spring around the firing pin with one end against this stop. The other end is braced against this shoulder in the bolt. Now when we pull back the firing pin, the spring is compressed. When we release the pin, the spring drives it forward against the primer. This is one way of accomplishing the step known as firing. However, it's awkward to pull back the pin and release it by hand each time we want to fire. We need a means of holding the pin back until we're ready to fire. This is known as cocking. Supposing we put a hook or tang on the rear end of the firing pin. We can still pull the pin back and release it by hand. Now we'll rig up something to hook it onto. But first, we'll have to add a block to the receiver to hold the parts we'll need. The first part is a latch-like piece known as the sear. If we hold it here, under the firing pin, we can catch the tang of the pin when it's drawn back. We'll mount the sear on this pin so that it will pivot freely. We can release the firing pin by pushing down the front or nose of the sear. This is where the trigger comes in. It's mounted on this pin underneath the sear. The trigger can now pivot back and forth. When the trigger is squeezed, it moves the rear end of the sear up. The nose of the sear moves down, and the firing pin is released. Once the sear is lowered, we have to move it back up to catch the firing pin the next time it's pulled back. That's why we need a spring, a sear spring, to push the sear up. It's installed underneath the sear. Now, when we squeeze the trigger, we lower the nose of the sear until it releases the firing pin. Then, when we let go of the trigger, the spring raises the sear nose so it will catch the firing pin when it comes back. The spring also returns the trigger to its original position. We no longer have to cock the firing pin by hand. As the bolt is opened, we can cock the weapon at the same time. The firing pin tang cams the nose of the sear down, and the sear snaps back up. As the bolt moves forward, the sear catches the tang and holds it, and the piece is ready to fire. That takes care of the step known as cocking. Now we have a basic firing mechanism similar to that used on a number of small arms weapons. But there is also another kind of firing mechanism. Some weapons use a hammer, which strikes the firing pin. We'll build this hammer type of firing mechanism on the model. First, let's attach the hammer so it can pivot and strike the firing pin. The spring was taken from around the firing pin to drive the hammer. The firing pin is retracted by various methods in different weapons, and it remains in the rear position until the weapon is fired. To guide the spring, a rod is run through it. The front end of the spring is braced against this shoulder. The rear end of the spring is braced against this supporting block. The rod is attached to the hammer so that the spring pushes against the hammer. When the hammer is pulled back, the spring is compressed. Then the spring drives the hammer forward against the firing pin. To cock this firing mechanism, we can use the same sear, trigger, and sear spring that we used before. When the hammer is pulled back, the sear snaps up into this notch, and the weapon is cocked. When the trigger is squeezed, the nose of the sear slips out of the notch, and the hammer is driven forward against the firing pin. This mechanism, like the other one, can be cocked simply by opening and closing the bolt. Squeezing the trigger fires the cartridge and sends the bullet out through the muzzle. But it also leaves us with an empty case in the chamber. Before we can get at the case, we have to perform the next step in the cycle of operation: unlocking. We still have the problem of removing the empty case from the chamber. This is known as extraction. On a real weapon, extraction is a serious problem. When a cartridge is fired, the case expands until it's tightly wedged in the chamber. We need something to grip the case firmly and extract it when we open the bolt. The part which does this job is known as the extractor. It has a hook to grip the extracting groove in the head of the cartridge case. The extractor is attached to the front end of the bolt. As the bolt is closed, the extractor snaps into the extracting groove in the head of the case, and it retains its grip as the bolt is locked. Now, when we open the bolt, the extractor pulls the case out of the chamber. Our next problem is ejection, getting the empty case out of the receiver. Notice how the case is held by the extractor. If we pry under the case on the side opposite the extractor, we can eject it from the receiver. If we take a slice off the edge of the bolt, we can get at the case more easily. Now we'll build an ejector in the side of the receiver. It consists of a small lever and a spring. We'll attach the lever so it pivots at one end with the other end held outward by the spring. When we push the bolt forward, the ejector is moved into the side of the receiver. When the case is extracted, the ejector slides into the notch, strikes the case, and ejects it. Let's watch it again. Our weapon is almost complete, but we still have to feed the cartridges to it one at a time by hand. The actual chambering of the cartridge is satisfactory. The bolt moves it forward and it enters the chamber. But once the weapon is fired and the empty case ejected, we want another cartridge waiting ready to be chambered. In other words, we want some method of feeding. There are several ways we can get feeding: by placing a clip of cartridges in the receiver, by using an ammunition belt, or by using a magazine. We'll use a magazine. One side is transparent, so we can see what's going on. Inside is a spring and this follower. As the cartridge is put in from the top, the spring is compressed. As the next round is inserted, the first one is pushed down and the spring is further compressed. The spring, of course, keeps pushing the cartridges against the top. But these lips prevent them from being pushed out. A cartridge can be removed only by sliding it forward like this. And once it is removed, the spring feeds the next one up into position. Now let's install the magazine into the receiver. The magazine is placed so that the top cartridge pushes against the underside of the bolt. When the bolt is opened, it slides back until the face of the bolt clears the rear of the cartridge. Then the cartridge is fed up into the path of the bolt. As the bolt comes forward, it strips the cartridge from the magazine and chambers it. And the spring in the magazine moves the next cartridge up into position. Now, each time the bolt is opened, a cartridge is waiting to be chambered. That's the last step in the cycle of operation, feeding. Our basic weapon is complete. It will perform all 8 steps of the cycle of operation. Let's take them in sequence. First, there's chambering, placing the cartridge in the chamber. Next is locking, securing the bolt in place behind the cartridge. Then firing, squeezing the trigger so the firing pin will fire the cartridge. Unlocking, freeing the bolt from the barrel. Next, extraction and ejection, withdrawing and throwing out the empty case. At the same time, cocking, preparing the firing mechanism to fire again. And feeding, placing the next round in position for chambering. Then the cycle starts over again. These are the 8 steps any small arms weapon must perform each time it fires a cartridge. The steps may not always come in exactly the same order, and the means of performing them may vary. But regardless of the type of weapon, all 8 steps will be performed. And once you know the cycle of operation, you've come a long way toward understanding any small arms weapon.